Life is too short to work at a crappy company. That's why Software Engineering Daily is proud to be sponsored by Hired.com, the job marketplace for software engineers. If you accept a job through Hired, they will give you a $2,000 bonus. But as an extra bonus to our listeners, you can get an additional $2,000. That's $4,000 total if you sign up by going to softwareengineeringdaily.com and using the link on the right side of the page to sign up. Hired.com will set you up with 5 great companies for interviews. These are companies like Stripe, Facebook, Uber, companies you would actually want to work for, where you can go and learn the cutting edge of software engineering. Go to softwareengineeringdaily.com, click on the banner on the right, and try out Hired.com. Anders Wallgren is the CTO of Electric Cloud and has a background in many different areas of software engineering. Recently, Anders has been talking and writing about IoT, that is Internet of Things, as well as DevOps, since his company Electric Cloud makes solutions that are very useful to organizations with a DevOps component. Anders, welcome to Software Engineering Daily.
Thank you. Glad to be here.
You've been talking about Internet of Things recently and saying that we're in a time where we need to start thinking about how to manage IoT software projects. But my refrigerator and my microwave and my TV, they still don't seem very smart. Is IoT something that is actually going to affect the broader population anytime soon, or do we have another decade or so until the mass market replaces their appliances and their cars with smarter devices?
I think it's a little bit of both. I think as far as cars are concerned, we're almost already there, right? If you buy a new car today, it's got 100 to 300 million lines of code in it already, and a lot of them, not all of them, but a lot of them are now internet connected, for better and for worse. For better in the sense that, if you're Tesla and you know how to update software over the air, you can fix bugs, just by updating the firmware in the car. For worse, if you're a large car manufacturer, whom I will not name because they're a customer, who happens to have online connectivity and doesn't know how to update the software over the air and has a serious security bug and it takes them 5 years to fix it. So for a small, number of cars in the grand scheme of things, but it's definitely, one of those things where there's going to be a few killer apps. I think we're starting to see a few, kind of deadly apps, maybe not killer apps, but, the Nest thermostats, the Fitbits and all those kinds of things that people are wearing, health monitors, those types of things are really starting to be popular. I think you could even argue to some degree that a smartphone is an Internet of Things thing. It certainly is what keeps a lot of us online and active and those kinds of things. And I think, I think the thing I'm most worried about is, what's the quality of these things going to be, and what's the security aspect of this going to be? I think there's, it scares me to death a little bit how lax the industry is about security sometimes, and also how, kind of ignorant not in a bad sense of the word, but how most people are, how most end users are to the implication of security in their Internet of Things devices.
What are the big security vectors that worry you?
So I think there's a couple that are of concern. I think one is just in general the fact that these things are on the internet, and so there is an attack surface by definition. Whether they're listening or talking, there is an attack surface there. And I think the other thing that is maybe of a little bit even greater concern, and probably will see the most attention first, is being able to do software updates over the air. That's also another potential attack vector, but it's also, I think, a necessary thing to be able to manage the functionality and security of the devices. And I think the way that things will work in the future is probably more along the model of the way Nest works and the way Tesla works, which is you don't really get to decide when the device updates. That's pushed out by the manufacturer. And I think that's the way it has to be. I think, most Wi-Fi routers in the world are, probably 99.99% are running the same firmware they shipped with, because people don't know and can't be bothered to go update their Wi-Fi router software. My mom certainly never will. And so a proactive updating of software, both for functionality and in particular for security, is absolutely required for the Internet of Things. I don't see another way that you could do it.
So you write that from smart homes and smarter appliances to automobiles and wearable technology, the Internet of Things has gone from a tech buzzword to a tangible and quickly advancing everyday reality. So we lump all of these technologies together in this umbrella of Internet of Things, but is it possible that each of these domains should be treated as a new platform in and of itself? Like when I think of mobile development, you talked about mobile could potentially be a subset of IoT. But when I think of mobile development, that's not really similar at all to developing on web. Maybe that's because of the way that the platform's developed and the SDKs and whatnot. But if we're lumping IoT in with automobile software and thermostat software and wearables, are we making a mistake? Should each of these areas have some domain-specific principles?
They should, and to some extent they do. I think the interesting thing about Internet of Things is that it touches most of the software stacks and software lifecycles that all these other things deal with, right? So, for example, you almost certainly have a back end somewhere. So you've got something sitting in a data center or in the cloud somewhere. You probably have some sort of application, some sort of mobile app or some sort of, app store app for pairing the device or controlling it or things like that. So you've got that. You probably have a website for doing stuff around that, registering and forums and support and those kinds of things. And then you've got the device itself, which is probably some sort of embedded device. So right there, you've got, back-end software, you got web software, you got mobile software, and you've got device, firmware embedded software. And so I think one of the interesting things about IoT is that it really spans, this whole gamut of different software life cycles. Now, you don't necessarily have to do all of them. You may not have a website. You may not, have a mobile app and those kinds of things. But, if you're, if you are a car manufacturer, your car is a device, and you probably, you probably have a mobile app for remote starting the car or unlocking the car or, those types of things. And when you manage those software life cycles, you've got to manage all of them. You might have to do a back-end update to add some functionality, as well as a firmware update and then a mobile app update in order to expose that functionality. So I think that's one of the things that makes IoT interesting to me, is that it kind of touches on all of these different things. But I also think that you're right in that, you can't look at it all. You can't look at the whole elephant at once, right? You kind of do have to look at, what is the individual life cycle of all of these things, and what is the kind of, the software life cycle around each of them.
Are you mostly an outside observer of this field, or are you working directly with companies to help develop IoT devices and talk to them about how they should manage their teams?
A little bit of both. So we have a pretty strong presence in the embedded and networking market. And in the embedded, especially in the network communications and mobile provider and communications provider type operations, and so we get exposed a lot to the problems that they have to solve and the types of life cycles that they have to live with. They're used to living in long life cycle type software. Well, as soon as you touch a mobile handset, in terms of maybe I sell a chip to a mobile handset to a manufacturer or something like that, your product lifecycle just shortened significantly, and your deadlines got very, very serious, because if you're a provider of communications chips to software companies or to mobile companies, and you miss a deadline, that's $1 million a day in penalties that you're paying your customer. And so the life cycles are very serious. You don't ship your iPhone late. You don't ship your Galaxy, S4, 5, 6 late. If you miss Christmas, don't bother, those kinds of things. And so I think what we're seeing a lot is both the kind of back-end IT aspect of this and the embedded aspect of this is probably where we get exposed the most. And then we also have lots of customers who are, I would say, not necessarily directly Internet of Things, but they're, say, medical device manufacturer, for example, which I would say is pretty close to an IoT kind of set up, even if you don't think about it that way. If you're wearing, if you're using some sort of medical device in a hospital and it's connected to the internet or connected to the network in the hospital, and it's hackable and it's remote configurable, remote diagnosticable, if that's even a word, and all of those kinds of things, then you're IoT whether you know it or not. And you've got to sort of act that way. So we are, I would say, more of an observer, and we get to see a lot of different aspects of this, and which is kind of interesting. That's what we like to do.
So you've talked about the broadening attack surfaces that come with IoT, which add to their different vulnerabilities, but one thing that really changed my perspective on this whole field was I did an interview with Vint Cerf, and one of his big concerns was that an army of IoT devices could get taken over and be used to launch a distributed denial of service attack. Is this plausible to you? And how do you deal with this kind of thing?
It's absolutely plausible, and it's a little bit scary because, we've got a lot of, say, smartphones are probably the most prevalent device that most people deal with these days, and there's billions of them. Well, by I think 2020, Gartner says there's going to be 26 billion IoT devices. So the recruiting has started for the distributed denial of attack army. I think it's a very serious thing, and these things are, they're real computers. They are running, they're running operating systems. They have internet stacks. They have, they're always on. They're always connected. There's lots and lots of kind of scary things about them, and I think there may be some serious roadkill on the road to the Internet of Things, right? Where we're going to see some pretty disastrous things. The way we've seen some pretty disastrous things in security on the Internet in general, with Heartbleed and with Target, and not to mention sort of the malfeasance kind of things like the VW shenanigans that we're looking at now. So yeah, it's pretty scary.
Yeah, and we've seen some botnet stuff, but a lot of it I feel has been kind of beneath the surface, relegated to ad tech, ad tech schemes. And, as this ad tech bubble bursts or gets punctured or something, I don't know, maybe people are going to be looking for things to do with that extra botnet bandwidth. And
yeah, it's who knows what people are going to get up to with it, right? Botnets are kind of scary. They're definitely capable of bringing down services and making it very difficult. And I think that probably, that's probably less scary for an entity like Google, who are themselves a giant botnet in some ways, but more scary for startups, or more scary for organizations or companies that are vulnerable. Whether you're an NGO, or you're a WikiLeaks, or you're somebody who's controversial, and all of a sudden a state actor or some sort of organization can harness 1 million or 2 million or 1 billion devices to kind of take you off the internet. That's pretty scary. And I think those kinds of things will happen, and we'll find ways to address them, but I'm pretty sure that it won't be done proactively. I think there's going to be a lot of closings of barn doors after the animals have escaped. And that's just, maybe I'm just cynical on this whole thing, but I just don't see that, everybody's going to hop on the security bandwagon right away. There's pressures to ship, pressures for functionality. Yeah, we'll do some lip service to security, but I think there's going to be some serious things that happen out there.
So this is kind of a tangent, but the whole, WikiLeaks gets shut down by a state actor, or somebody else gets shut down by some kind of state actor. Is attribution on these kinds of attacks getting harder and harder? Or is it just already so hard that we can't attribute attacks consistently to anybody?
I can't imagine that it's getting easier, right? and once you're dealing, and it's one thing if you're dealing with 50,000 bots out there. Once you're dealing with a huge, vastly larger number of them, attribution will get a lot harder, a lot more difficult. And maybe we'll come up with some ways to make attribution easier, but there's a flip side to attribution, which is it destroys anonymity. right? So if you could easily just say, all right, I'm king of the world, and I'm deciding that there will be no anonymity, so everything is perfectly attributable on the internet. Well, that doesn't work either. So sort of by definition, the internet can be a very anonymous kind of place, and that makes attribution difficult, on a technical level.
Right. So the IoT denial of service stuff, different kinds of attacks, that can be a problem. But on the other side of the spectrum, there's simply the hurdle of getting to this level of adoption that people dream of, where our entire home is connected and whatnot. And, it's still hard for me to imagine this point of integration, this fabric that binds different IoT devices together. Given that you've been kind of like studying this area for a bit, what do you see as... do you have a plausible roadmap to what happens here? Like, is it going to be Nest? Is it Amazon Echo? Is it the Google On Hub? Or do we even need a common API, like a common layer that binds these things together?
I mean, I think the more of that there is, the more interesting stuff you can do, right? I mean, it's certainly more interesting to me, if I can talk to Siri on my iPhone and tell her to turn on the lights because I'm about to, get out of the elevator and it's dark outside. And not have to fumble with my phone and click buttons and all that kind of stuff. I mean, in some ways, that's a fairly trivial example, but to get to the point where that works, you actually have to get a lot of things to work. So I think platforms for doing this type of thing will be very interesting. But do I think sort of magically all of a sudden, my refrigerator will talk to my wallet, which will remind me to buy milk, like that kind of stuff. I think we'll see kind of pairwise interesting functionality. But I don't think there's going to be this whole world of kind of agents out there acting on our behalf. I think that's kind of, that's a little far-fetched and certainly way more in the future than anything else. But on the other hand, Google starts to notice that I'm interested in a particular sports team, and all of a sudden it says, hey, the game's on at 4:30. Do you want to watch it? And so there's lots of kind of ambient information in your behavior on the internet that you can use to do interesting things, maybe interesting / scary things in a privacy sort of way. But if you assume perfect privacy, very interesting stuff, very helpful stuff can happen. And I think that's kind of exciting. I mean, I think there's going to be some pretty cool functionality and some pretty cool products that come out of this.
What do you mean by that? Assume perfect privacy?
Well, so privacy is a little bit scary on this stuff, right? Because if I buy a smart television that I can speak to, how do I know it's not always listening to me? And if I have if I buy an Xbox One with its Kinect, how do I know it's not always watching me?
Right. So this is like the example. Somebody was telling me they have an Amazon Alexa, and supposedly Alexa is only always on in the context of the trigger word. Like right. It's never connected to the internet unless you say, Alexa, do whatever. Yeah. But this person told me that she was like adding something to... Or she was on the phone with somebody, and she's like, oh, yeah, I'm going to go to the store and do this. And she hung up, and then, like, Alexa said, do you want me to add this to your shopping list? and I was like, I almost, like, didn't believe it, but this is, like, a fairly reliable person. So I was like, okay, I guess Alexa is always on.
And even if it's not always on by design, maybe if it gets hacked or there's a security problem, now it is always on by design. So right. If you take privacy as a problem off the table, you can have some pretty lofty ideas and some pretty interesting stuff that you can do. And then you have to think about what are the privacy implications of this, what are the security implications of this, and those kinds of things. And I don't wear a tinfoil hat, so I don't necessarily believe, that there's nefarious behavior happening here. But there are serious security and privacy implications of these kinds of devices. If you always know my location and you always know my heart rate, you can probably tell a lot of interesting things about what I'm up to. And that's both a little bit scary and maybe, a little bit interesting. So I think there's going to be a lot of cool things that will be done, and there will be some pretty awful things that happen, but we'll get over it like we do with everything else,
Yeah. So these IoT companies, they're going to develop products one way or another. And it's going to take a certain organizational mindset to move the ball forward correctly. even if we're not talking about like ethics or propriety or whatever, just like moving things along in a way that, allows your devices to ship on time and whatnot. And so you wrote an article that was kind of touching on this, like how do you manage an IoT company? And it was called As IoT Expands, Agile is the Way Forward.
Yeah.
And Agile is a word that has been overloaded and used in many, many different contexts.
Oh, yes.
What is your definition of Agile in the context of IoT software development? So
I think what it sort of fundamentally comes down to is iteration. That's really the key aspect, right? Because if you're say a company with a website, right, and you run the back end yourself, you have complete control over the lifecycle of that application. You can do whatever you want to it, and it's you can go very fast. Now, once you start to look at the world of not just ALM, application lifecycle management, but PLM, product lifecycle management, sort of the physical version of ALM, and you're designing a device, a device with buttons and with a CPU and or system on a chip and a network stack. Now you've got these two life cycles that don't necessarily work together in the same way. The iteration lifecycle of software is generally a lot faster than the iteration lifecycle for hardware. And yet these two things kind of have to align and work together. And especially in order to get a good, decent 1.0 out, you've got to get as much iteration on that as possible. And a lot of the differentiation is going to be in software, obviously, but also in design and hardware as well. And so I think the more that the hardware side of the house and the software side of the house can get together and iterate, together, the better off you are. And that's a concept that's still a little bit foreign to most hardware vendors. You really, you have a different kind of life cycle when you have to tape out a chip, right? That's a big deal. Once you tape out the chip, it's very expensive to fix problems. And so they tend to be very careful about that and not try to iterate on that quite as much as they do to try to get everything done up front. I think that will probably change a little bit, and we'll have lots of platforms out there that you can build your devices on so that you don't necessarily have to have so much, kind of taping out of chips. If you can buy a $5 Pi Zero off the market today, just imagine what you could do a couple of years from now, in terms of that thing being tiny, 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 and now you're building a device around it. And so I think, the iteration is really what's important there, and that's really what I was getting at with the reference to Agile.
Yeah, and you mentioned this hardware and software teams working in collaboration. That sounds like faintly reminiscent of DevOps and reducing this wall of confusion. Yep. where software teams will throw something over the wall of confusion to operations people. You're kind of saying, oh, this is actually applicable to the hardware software barrier as well. Is that is that something you're thinking about? Like is this the continued story of DevOps where we're trying to figure out how to surmount these walls of confusion?
I think that's a great analogy. I think that's a great sort of point to make, which is there are a lot of these barriers, right? I think one of the things that makes Apple as good as they are with hardware design is that they take different disciplines and force them to work together. There was a great article. It was a couple of weeks ago. I forget where I read it, but it was an interview with Phil Schiller at Apple, and the guy almost never does interviews. But one of the interesting things they talked about was how, in order to get these devices designed as well as they are, they have to make and the example he used was, we took the antenna guys and we took the speaker guys, and they had to work together because they had to fit their devices into the same little, piece of the puzzle. And they managed to figure out how, we're going to carve a tiny little groove in the speaker assembly, and the antenna will come out through there. And,
wow.
So, in the end, they had people that knew a lot about speakers that knew a lot about antennas, and people that know way more about antennas that now know a lot about speakers. And that's just one example of how you kind of have to break down those disciplinary barriers between different disciplines to achieve great things. And to me, that's just that's what DevOps is. That's what Agile was between dev and QA and product owners, and really bringing everybody to the table as opposed to this kind of waterfall, throwing stuff over the wall kind of thing that we've been doing for so long.
Okay, right. So that's Apple,
Yes.
But Apple is not necessarily the company that's doing the IoT development.
Yep.
If you talk about a company like Maytag, or I don't know if they're your client, or Honeywell, you mentioned in your article, you mentioned Honeywell. You said Honeywell is venturing into the world of connected thermostats, and it's changing their business. Can you tell that story? Like how did Honeywell, for example, change as a technology organization when they started going after connected thermostats?
Well, it's one of those things where all of a sudden you have all these things to worry about that you didn't before. Right. I mean, Honeywell, with their iconic, rounded design for their thermostat, which Nest sort of borrows from in a design kind of way. They've never had to worry about this, right? What little software there might have been in their thermostats was generally, do I have 5 days of freedom in programming my thermostat or 7 days of freedom? And do I operate with heat pumps or don't I operate with heat pumps and those kinds of things? And now all of a sudden it's, well, I need to have some sort of application to control this thing, and I need to have a back end, and I need to layer security on top of it. And this is not their core competency, right? This is new to them. And I honestly we don't work with Honeywell as a customer, so I don't know whether they, did they branch out on their own? Did they hire a team? Did they buy a company? I don't know how they accomplished that. But it's interesting because now all of a sudden they're completely out of their comfort zone, right? This is
probably Accenture.
It may well be. But they, whatever they did, you can count on thousands of other companies doing the same, right? And it's kind of the same as with mobile apps, right? I mean, most large companies don't have a competency in mobile apps, and so they use either boutique firms to do it or freelancers or those kinds of things, and sometimes it shows. Sometimes you can tell that they built a screen scraping app on top of their back end as their mobile app. CVS, I'm talking to you. State Farm, I'm talking to you. And sometimes you can tell that this thing was built from scratch by people who understand what mobile is. And isn't just a very tiny website, kind of on a mobile app. So that it's different kinds of competencies, and it'll take a while before that competency spreads throughout the industry to where a Honeywell can hire that competency as opposed to sort of contract it out. But it will happen.
So that's almost chilling to think about, because I think about like the CVS app or the State Farm app. I wouldn't touch these things with a 10-foot pole. Like I am always, whenever I have to access that kind of information on my phone, I'm always like going through email or through my browser or something. I'm not going to download these apps. But if that's the level of quality that they're going to be, that these like IoT companies are going to be bringing to their quote smart devices, that is bone chilling.
It is a little bit scary, but it's a growth process because if you think back a while. Websites were the same way a long time ago, 15, 20 years ago, right? A lot of websites that people put up were basically screen scraping off of, 3270 mainframe applications. And it showed, and because that's the fastest way that you could get something out and the easiest way that you could get something out. It didn't require, rebuilding everything from the ground up in order to provide APIs to things that never had APIs before, right? But now if you go to wellsfargo.com or even statefarm.com, those are real websites, right? They're not fake websites the way they used to be, and the way that their applications are kind of fake mobile apps right now. So I think that's just part of the growing pains of the industry, and it's it is at least an acknowledgement on the part of these companies that, hey, this stuff matters to our customers. This is how they want to access our business. This is how they want to do business with us, and we better do it. Now, maybe they don't do it as well to begin with, but they'll get better at it. So there is hope.
Yeah. Yeah, definitely. Okay. So you write that one of the complications of Internet of Things development is that, quote, as the complexity in designs increases, product and security flaws are discovered. This is sometimes due to the many manual steps that are often skipped during the development process. What do you mean by this? What are the kinds of steps that are skipped during product development?
Well, I think as if you have a largely manual process for your software lifecycle in terms of testing, in terms of security, and those kinds of things, it's very easy when you're under time pressure to just skip those, right? We're trying to ship. It's going to take us 3 days to run our security checks. And we don't have that time, so we're not going to run them. So
this is like manual testing versus a Jenkins build.
Exactly, right. It's if you bake these things into your pipeline from the beginning, then they're always done, right? And this is one of the things. In the beginning, DevOps was a pretty scary thing to ops people and to security people and to network people because they kind of felt like, well, hey, wait a minute, you're kind of reaching behind our back to put code into production, and we don't like that. But in reality, what happens when you do it right is that their concerns are met by the pipeline. So if you're a security person and you've got certain static analysis and dynamic analysis and fuzz testing and those kinds of things that you want done, you put that into the pipeline, and it happens on hopefully every CI cycle, but that's probably not realistic from a time perspective. But it happens at least automatically as part of the release cycle, and therefore you don't kind of have to stress over whether it ran or not because it's been running during the whole development process. And the same goes for, if you can automate your QA to a great extent, then you have much more predictability about what you've done throughout the life cycle. And when you get to the end, when you're always crunched for time, no matter what you're doing, then you have much more confidence over the fact that, hey, you know what? We've been running our security checks all along, and we've been running our automated tests all along. And we've been running our code coverage all along and our static analysis and, this, that, and the other. And when you get to the time crunch, you know that you haven't skipped that stuff. And as opposed to the way that we used to and for a lot of us still do these kinds of things, which is security is something that we do at the end of the life cycle. Performance testing and load testing is something that we do at the end of the cycle. Well, those are the worst times to do it, right? Because those are it assumes that you can fix a performance problem or a security problem with a couple of lines of code change, right? Which is never the case, or almost never the case.
Yeah, the incentives are all out of alignment.
Exactly. Yeah. And so you want to push that stuff as far to the left as possible. And that's really where Agile and DevOps and continuous delivery and all of these kinds of things help us in getting that stuff done.
And tester and development, it sounds like.
Yes, absolutely.
Over Thanksgiving, I had a great idea for a web app. So instead of spending time with my family, I locked myself in a room and I started building this application using Express.js because I love full-stack JavaScript. So I was testing my application locally and I was making great progress, so I decided to deploy it and share it with some of my friends and get some feedback. I used DigitalOcean. I signed up for an account using promo code SEDaily, and in 15 minutes, I had my app deployed to a server and running. It was that simple. This was really the first time I had used DigitalOcean. So if you're like me and you like building stuff and you have ideas for projects, give DigitalOcean a shot. It is the fastest and simplest way to deploy an application that I've ever used. If you want to give it a try, go to DigitalOcean.com and use the promo code SEDaily to get $10 in free credits. Check it out. So you write about the importance of testing and simulations, saying that, quote, with the power of simulations, organizations are able to automate any function within the simulator and then fully test it. But it seems like one of the big problems with testing IoT devices is sensing the outside world and dealing with these, kind of edge cases that you might not think about until you put the thermostat up on the wall and start testing it. And if your sensor is broken, your software won't behave correctly. But the faultiness of sensors, I don't know, doesn't the faultiness of sensors undermine the effectiveness of a software simulation?
I think in the end, that problem is still there, but I don't think it invalidates the use of things like simulators and those kinds of things. The point, you're going to have to do system testing, let's call it, right? You're going to have to put that device in a freezer. You're going to have to put that device, in some hot oven to bake it and make sure that it still works, and all of those kinds of integration testing things that we do. What you want to do with things like simulation is get all the other crap out of the way, so that by the time you actually have the full system up and running, the kinds of things you're testing are the things that you can only test with the fully functioning system, as opposed to the things that you can simulate, right? Because you're going to have the least amount of time and the least amount of resources probably put to kind of that full cycle testing, because that tends to happen later in the life cycle. So I think it's all about shifting stuff to the left that you can, right? Do unit testing so that you don't have to write complicated integration and system tests. And so that you only have to write the system test that really does exercise the full stack all the way through from the device to the back end, to the database, to the cloud, to all of those things, and that you've done all of your other easy testing up front. And so you spend your time, doing the hard testing when you finally have everything up and running.
So we've talked about a little of this stuff in theory and a little bit in practice. Like, in practice, you gave the example of Apple bringing together the antenna guy and the speaker guy. And you also write that in the IoT world, quote, consumer expectations are fueling the need for more collaboration between teams. In terms of collaboration, like, I think that brings us really to the conversation about DevOps. Software Engineering Daily did a week of shows about DevOps, and there was actually a lot of contention around the definition of what DevOps is. But certainly collaboration is a word that fits into this discussion. If there's one thing that I understand about DevOps, it's that operations people don't like software being thrown over this wall of confusion, and that collaboration is really key. So, I mean, how does this collaborative effort work in practice? I mean, we can talk about like the bucolic world of Apple, but more realistic software companies, how do they bring this DevOps world to the table?
I think that becomes one of the hardest things to do, especially in an established company. And I think, kind of the three legs of the stool are kind of culture, process, and tooling. And I think process and tooling are the easy ones. And I say that as a guy who sells tools and helps with process for a living, but culture is really the most difficult thing, because there's been this, and not because we're stupid, right? But there's been this siloing of efforts over the years, and a lot of that has to do with specialization, right? Because you typically can't have somebody who really understands everything to the depth that you have to understand it to do it. There's going to be very few people in the world who know everything there is to know about web design and JavaScript and browser behavior and database design and JDBC behavior and database idiosyncrasies and scaling and security and networking and all of these kinds of things. And so the what I don't want to do is sort of throw out the baby with the bathwater, which is don't get rid of specialists, but do employ more generalists. I think is a good thing. And then I think what we've done is we've made our organizations mirror kind of our specializations, right? And then we've got all your incentives are going to be different, because if you're an ops person, your job is to keep the lights running and the money coming in, right? If you're a dev person, your job is to innovate and build new functionality for your customers or your future customers. In order to get that into production, you have to change the operational environment. Well, what does an ops person not want to do? They don't want change, because that's when things go wrong. And so if your reporting structure and your incentivization structure and all these things are set up around measuring, downtime and measuring, incidents and all these kinds of things, and not on anything else, you get some perverse behavior. I mean, you get the kind of behavior where ops says, no, we're not doing more than one, deployment a month, right? Because it's too scary and too many things break and, those kinds of things. Whereas, what you really want to do is say, look, what is our overall goal here? Our overall goal is to deliver functionality to our customers. In order to do that, we need to A, create the functionality, and B, deliver the functionality. And we've got to treat that as one kind of one problem that the company as a whole, the organization as a whole, is trying to do. And when we silo, we tend to set up these sort of perverse behaviors and perverse incentives that are measurable, but not necessarily directly benefit the customer, directly benefit the organization as a whole. And so what DevOps tries to do or one of the things that DevOps tries to do, as well as continuous delivery, as well as Agile and all of these other kinds of techniques, is to say, look, let's take a little bit more of a holistic view on this and realize that we have to be able to deliver functionality more quickly than we have in the past. If we're going to do that, we have to, the two big things about, kind of deployment is if you want to get better at it, you have to do it more frequently. And if you want to screw up less when you're doing it, then do it in smaller batch sizes. If you do it in smaller batch sizes, you will deploy faster. And when you do have a problem, I should say, you have a much smaller set of change lists I have to worry about to figure out what went wrong. And your mean time to recovery when you do have a problem will be a lot faster. And you're in a much better position to roll forward as opposed to roll back. And lots of other, green, blue deployments, canary deployments, all of the kind of techniques and things that we can use to maintain reliability and uptime while at the same time being able to deliver software faster. So I think it's, we've specialized a lot because we have to, but when specialization turns into siloing, that's kind of when you get into trouble as an organization. And that's difficult to undo because, you almost have to reorganize the company in some ways to make it work better.
Yeah, I had a conversation with Carmen Deadro, who is he's like chief of technology at Nationwide, I think, and he was talking about moving Nationwide, which is it's like 100-year-old company or something, like super old, to DevOps, and just discussing the cultural barriers to that, the technological barriers, was very interesting.
They are significant.
Yes, they are significant. And I think it's like you said, the cultural is the hardest part. Especially you take a 100-year-old organization like that, that company has gone through a time where waterfall was lauded. And in my entire, 6 or 7 year career as a technologist, the entire time, I've never worked at a company that has said waterfall is a good thing. It's always it's only used in mockery.
Even if they still use waterfall, they'll say it's a bad thing. So
yeah, exactly. Right. So anyway, you're the CTO of Electric Cloud, which makes products that are useful to DevOps organizations. I know we're nearing the end of our time, so I'd like to discuss some about, what are the products that Electric Cloud develops? How do they help organizations with a DevOps mentality? So
I think, we have two fundamental products in our portfolio. One is Electric Flow, which is an automation platform with lots of really good bespoke UIs on top of it for doing build, test, deploy automation. Basically, laptop to live automation. To coin a phrase, so to speak. And the other one is Electric Accelerator, which is a build and test acceleration tool that basically lets you throw hardware at the problem and get pretty serious acceleration out of some of your build and test efforts. And I think there's a couple of things that we really focus on with customers, and one of them is automation, getting the human out of the loop where the human doesn't belong. And automation, and a lot of people are doing automation in a siloed fashion, right? There's build automation on the one hand, there's test automation on the other, and then there's maybe some deployment automation at the tail end, but none of these things talk to each other. And so you don't really have an end-to-end view of what you did. What did I just push into production? Why did I push it? Who contributed to that? What change lists were involved? What requests were involved? How do I know that we ran all the right tests? How do I know that we followed our pipeline and all of those kinds of things? And so making sure that you can have an end-to-end view of your entire software lifecycle is one thing, and automating it, which just by automation is acceleration is one thing that I say a lot, because once you automate something, you take the human out of the loop, and you've automatically almost every time gained hours, if not days, out of every little handoff that you've automated. And then the second thing that we focus on a lot, in addition to the automation and kind of the flow stuff, is just acceleration. Make all of this stuff faster. If you have a CI process that's too long, can we make the build faster? Can we run the tests in parallel instead of all serial in order to make your CI cycle faster, or to squeeze more testing into your CI cycle as it stands? In an ideal world, we would have a zero-length build and test cycle, right? You get immediate feedback, and we ran the entire stack of testing, right, in zero time. Well, we don't live in an ideal world. We're resource constrained. We're constrained by the laws of physics and all kinds of other silly laws. And so we have to really look realistically at, look, if I want a 15-minute CI cycle, how much can I get done in that 15 minutes? And if I can get more done, that's better, because that means I'm not pushing it to later in the cycle. Not doing it daily or weekly or monthly or once per release, those kinds of things. So helping our customers understand their processes, automate them, bring them all together so that they're not siloed. You don't have silos of automation the way we have kind of silos of behavior now, and then cutting down on the cycle times. Those are really the things that we work with our customers and our products to do.
Yeah, great. Well, Anders Wallgren, thanks for coming on to Software Engineering Daily. It's been awesome talking to you about Internet of Things and DevOps and all kinds of other buzzwords and explanations of buzzwords.
Likewise, yeah, it's been a real pleasure, Jeff.